Hello everyone, welcome to lecture 3.4. We're going to introduce a image blur example. Objective of this lecture is for students to learn a two-dimensional kernel with more complex computation and memory access patterns than what we have seen so far. This slide illustrates the image blurring computation. On the left-hand side, we show the original image. On the right-hand side, we show the blurred image. In order to calculate the output pixel value, we take the corresponding input pixel position and we draw a surrounding box around that position, and we take the average of all the pixel values in the bounding box and use the average value for the output pixel in the same position. This particular blurred image is calculated by taking a surrounding box that is 4 pixels in each direction of the original pixel value. For the purpose of this lecture, we're going to use a fairly rudimentary blurring algorithm. Just like the RGB to grayscale kernel, we're going to use one thread to calculate one output pixel value. For each thread, we're going to take the output pixel position and draw a surrounding box around that output pixel position and take all the input pixels in that surrounding box and calculate the average value of all these pixels. And we're going to use the average value as the output pixel value for that center position. Now we're ready to present the image blur kernel. The first part of the blur kernel is not any different from the image processing kernels that we have seen so far. Each thread is going to be responsible for output pixel, whose column index and row index will be calculated based on the block index and thread index values. And every thread is going to be checking whether the column index and row index of the output pixel value is within the valid range of the picture. The rest of the blur kernel is more interesting. As we can see, the blur kernel is much more complex than the RGB to grayscale kernel. Here, for each thread that is going to be participating in the calculation of an output pixel value, it's going to use a nested for loop to visit all the pixels in a surrounding box of the particular input pixel that is responsible for. And the particular input pixel coordinate is identified by the COL and ROW variable. COL gives the column index and row gives the row index of the particular pixel position that this thread is responsible for. So the two for loops will systematically take the visit the pixels in the surrounding box by visiting up to blur size rows above the center pixel and to blur size rows below the center pixel. And for each row being visited, it will visit up to blur size column to the left of the center pixel and blur size to the right of the center pixel. So in total, we're going to visit 2 times blur size times 2 times blur size, essentially 4 times blur size square pixels around the pixel position that this thread is responsible for. For every pixel being visited, we're going to verify that the pixel position is within the valid range of the picture. And if so, we're going to add the pixel value into the total pixel value within the surrounding box. And we're going to also keep track of the total number of pixels that have been accumulated into the total pixel value variable. After we have visited all the pixels in the surrounding box, the thread will divide the total pixel value of the surrounding box by the total number of pixels that have been accumulated into the total value, and this gives the average pixel value in the surrounding box. And the thread will write it into the particular output pixel that is responsible for. This completes lecture 3.4. Thank you.